perfectly. Hey guys, today I have a special treat for you. This is my new gearbox, but this isn't just any old project of mine. This project, I'm going to go through the whole CAD modeling process, and this project is a replacement gearbox for the modular robotic arm project. So this gearbox will have the exact same form factor as the one in the link below. I'm going to go through the whole process in Fusion 360, showing you guys how to model this gearbox and showing you how I designed it with my Arduino program. The thing I wanted to say about the Arduino program is originally when I started making this video, I intended to release the program with the gearbox. Now I've kind of changed my mind on that, but eventually if you subscribe to this channel and like this video, you will get this program, this Arduino program that you will see in just a minute, and you will have access to any differential planetary gear ratio that your heart desires. So just recently I've written this program for Arduino to automatically calculate the gear ratios that will come out of a differential planetary. And I'm going to use this to get the gear ratio and the numbers of gears that I need to use to make this differential planetary work right. I'm not sure what gear ratio I used for my last gearbox that was this form factor, so I'm going to go on Thingiverse and find out. 43.3 to 1. So I just want to stay away from that exact ratio. I'm going to change target gear ratio to 100. And what that's going to say is it's going to randomly try a bunch of different differential planetaries, and when it gets one that's close to 100, it's going to save that gear ratio that one actually is, and then it's going to keep looking and keep looking. And if it does eventually find one that's closer to 100 than the last one that it found, it will save that one, and it'll continue down that road. So I'm going to say max teeth is going to be 15, because I really don't want any more than that. Max ring teeth, I really don't want to go above 50. Minimum teeth, I really don't want to go below 10. Minimum planets, I really want to keep 4. Max planets, I really don't care to go above 6. Sun planet factor, that's just how much bigger planet gears be than the sun gears. That really doesn't matter for this one. Set outside diameter, so to figure out what that has to be, basically what I want to do is just match what this one was, and I believe that this should work. So 34.332. I'm going to just round that down to 34 and go with that. So what that does is it'll tell me the module of the ring gear to use, and that's really nice because then I don't have to do the math on it myself. I've already done the math in this program. And then so show all combinations, I'll just go through all these settings on here. Show all combinations, what that does for me is it like every random ratio that it finds, it'll show it. So you could literally get every possible ratio if you want. Of course you'd have to go through and do some other things, but target gear ratio, just went through that. Max gear ratio, for some reason this program, I can't figure it out. When it takes two planetary gear sets that are identical and makes a differential planetary out of them and does the math, it'll see the gear ratio as infinite because it technically is. So I had to say if the gear ratio is above 100,000, don't even show it to me. Now that I say that, I wonder if maybe that's the reason why I haven't really gotten above that. Huh. Anyways, so what I'm going to do is upload this to the Arduino. I'm running this in an Arduino Do. So the first thing this program is going to do is it's going to take and figure out every possible combination of gears that you can put into a planetary gear set with the constraints I've put on it. And then it's going to take all those planetary gear sets that it came up with and try to, combine them together into a differential planetary arrangement and figure out what the gear ratio is. From there, it tries to get as close to a 100 to 1 gear ratio as it possibly can. And then it'll try it with different numbers of planet gears. And then also you see here the gear ratios that are negative. That just means that for 68 rotations of the input gear, the output gear will spin once, but it'll spin backwards. So I'm getting not exactly what I wanted. I'm hoping it gets much closer to 100. So maybe I have too many constraints. Maybe that's the deal. How can I constrain this less? I could go down to 9 teeth, or what did I use before? 1, 2, 3, 4. I used 8 teeth before, max ring teeth. Let's jump that up to 70. Let's do 60. There, now I'm getting pretty close to what I wanted. 99 to 1. Let's see what kind of values it's giving me. Okay, it's 20, 10, 40, 17, 8, 33. That's really good, actually. The only thing I don't like is when you get 8 gear teeth, it's hard to do that. So let me check in Fusion, see what the pressure angle is if I use 8 gear teeth. Basically what happens here is if I go down to 8 gear teeth, I can't use a pressure angle of 20 anymore. I can use 30. Can I use like 28, 27, 25, 24? Oh, didn't like that. Okay, so 24 is as low as I can go, which is still pretty good. Look at that, these two have identical modules. 13, 12, 37, 14, 11, 36. I'm going to do this one. I'm going to do this one because I like the idea of using the exact same module. It makes it really easy to model. And although it can make it confusing to assemble, it will still be assemblable. Okay, so let's see what this turns out to be. Ring gear has... So the minimum amount of teeth that I'm using is 11. And I want to see, yeah, I can't use pressure angle of 20 on that. I can use 21 though. And that's what I'm going to do. So module is 0.8718. Your parameters. Come on, now I just want to see the outside diameter. Oh, okay, so I need to change that to the number of teeth in my ring gear, 37. Outside diameter is 38. That's way too big. Yeah, what did I punch in for my outside diameter that I wanted? 34? And it's... The problem is that if I set this helix angle to 0, there's my outside diameter gets to be... okay, if I set it to 0, now my outside diameter is perfect. I didn't figure for the helix angle in my Arduino program because I didn't know how. But that's okay, because both of these gear sets actually, like, luckily enough, have the exact same module, which means that I don't need to get all fancy on it on this 87.18, and I could just go, so I need to hit outside diameter of 34, so I could just try 0.7. That knocked my outside diameter down quite a bit. Okay, 33.5, that's perfect. And it's a nice 3/4-ish of it, a whole number. So, gear thickness. I need to figure out what I used on my last one for gear thickness. I believe I made them this. Just check. Okay, so I did. So they're 10 millimeters wide, and I need to mirror them. So I'm going to go 5 millimeters wide. I have to go back to my 37 teeth. And that will give me outside diameter of 33.45, and that's just perfect. Handedness, right. The ring gear and the planet gears have the same handedness, and then the sun gear is actually the opposite. The reason for this is that the ring gear actually gets subtracted from a cylinder in order to make it an external gear with the teeth on the inside, and that's why that is. So backlash on the ring gear, I normally negative 0.2, and I got my teeth right. Now when I go to make the 36 tooth ring gear, the outside diameter is going to be 32 millimeters. So that's a bit of a difference, but not a big deal. So I'm going to make the 37 first, right-handed, helix angle, pressure angle. Ooh. I'm going to do 22-degree pressure angle because I can't do 20. I know that because when I go down to the 11 tooth gear, yeah, I could do 21. That works. Let's just do 22. So back to 37. Okay, so this is my first ring gear. Backlash now becomes positive, and I'm going to put it at point, say 0.5, 0.1. I'm just making this shit up as I go. Now, sun gear, 13 teeth, left-handed gear, backlash, keep it the same. Okay, and on to ring gear number 2, 36, negative 0.2 backlash, right-handed, planet gears number 2, 11, 0.1 backlash, positive, right-handed, and sun gear number 2, 14 teeth, left-handed, backlash positive. One thing that I think is kind of interesting is when you actually see the way Fusion 360 lays these gears on top of each other, you're seeing the outline of all these gears that are piled up on top of each other, and it makes it kind of obvious how this works. It really reminds me of a harmonic drive and how these teeth are just slightly off of alignment all the way around until they get to here, and then just slowly kind of changes throughout. And I think that's interesting because it really kind of physically can show you how it works in such a different way. I need to move this gear 10 millimeters plus the one that I have for space between them, and I have to move these two the same. Okay, so this is module 1, this is module 2. Now, when I say module, I'm not talking about the module of the gear teeth anymore. I'm talking about module as in slices of the gearbox. So when I'm done with this, I'm basically going to take module 1 and I'm going to add it over here, and then I'm going to take module 2 and I'm going to move it over there, and that's what's going to give me 4 modules. So 1 and 3 are identical and 2 and 4 are identical. So the next step is to take and move my planet gear to where it's supposed to be between this ring gear and the sun gear. But the problem is if I just simply try to move it there and guess and do this whole number of everything, it's not going to be perfect, and it actually kind of needs to be perfect, because if this one's off a little bit and it's not perfectly centered on this other planet gear that's hidden behind it, I'll show you that. If this planet gear is not perfectly centered on this planet gear, you will actually have a gear that'll it'll be like a crankshaft, and it just won't work that way. So you actually have to use math and figure this out. Anyways, the way I'm going to go about doing this is I'm going to take the number of teeth on planet number 1, so 12 of the sun gear, pitch diameter is 11.258, 10.392 plus 11.258 divided by 2, 10.825. I'm going to take and move this gear 10. Maybe I'll go this way. 10.825. Okay, so it's meshing there. Now I gotta rotate my sun gear to match that. And this I don't have a mathematical formula for. This I don't know. Now I'm gonna get rid of these 3 and do the back one. Okay, so that one's already matched up to the sun gear. That's okay, perfect. So the second thing I'm going to do now is, that's a 5 planet set. So I'm going to make sure that I can fit all 5 planets around on it without them colliding, because, you know, the script I wrote isn't perfect. There's something of doing a pattern of bodies in Fusion 360 that I've always had trouble with up until a certain point. And that is that if you do a pattern of components, say if I took just this component and did a pattern and told it to put 5 of them in here, then when you actually try to go and rotate the gears so that they are, all the gear teeth are lining up, as soon as you rotate one of them, all 5 of them will rotate that amount, and it's super annoying. But if you know that you go and click in and click on the exact body and say that you're going to do a pattern of a body, and then you select the axes at which you would like to do that. In this case, I'm going to turn on the origin and use that. And then I'm going to tell it to fit 5 of them in there. And look at that. There's 5 gears around there. I just got to go and straighten them out one by one. Okay, rotate each planet 235.6364. First I got to set this. I don't know why it does that either. There we go. So these should all be perfectly spaced and awesome now. Pattern bodies, axis, use the z-axis. There we go. So this is the essential design behind a differential planetary that I make. Now I'm going to go and I'm going to make the external parts of the rings, and I'm going to subtract this gear from that. And then I will start combining the planets together and the sun gears together where I can. So now I need to get the exact outside dimensions. Look at that. It's even in the right orientation. So, could have made these planetary gear sets a bit bigger, huh? Well, that's okay. The ring gears will just have a little bit more thickness now than they did before. So, what I'm going to do is I'm going to make a new component, and I'm going to make it on this plane. So, I don't want to make it from this direction. Okay, so what I'm going to do is I'm basically just going to copy the dimensions of this other part, so that this will fit the exact same as it did before. So I'm going to go ahead and turn off all these gears, so I cannot see them. Extrude this out. I'm going to do 10 millimeters, but since there's a 1 millimeter gap between each module in this gear set, I'm going to make it 10.3. So then if I made it 10.5, all these ring gears would be super tight to each other and they would cause a lot of friction. But if I go, actually I should do 10.4, allowing them the ability to support each other, but not to put much of any friction on each other. So this is what I'm going to do. I'm going to subtract my ring gear from this. And I'm going to turn this sketch back on and extrude this. I'm going to make this a new body, and there's a reason for that. I'm trying something new here. This is going to save me a lot of the work that I've done before and wasted time on. Maybe I'll go up to 0.5. So now I'm going to get rid of that sketch. I'm going to extrude this back. Same on this side. And then I'm going to give this a chamfer here and here. Hey, look at that. Yeah, that's a very 3D printable object, I think. So all those marks on the outside of the rings will now be a little bit easier to deal with, to get them to line up with everything. So now I'm going to do a pattern on this body. I'm going to do it off this axis yet again. I'm going to do 16 of them, and since there's going to be a gap in the top of the rings, I'm going to get rid of that one and see what that looks like. Now I'm going to do a combine, and that way I don't have to go around and edit each individual one of these, which I've done before, and it just was not worth the work. Okay, so now I'm going to hide this for just a second, and I'm going to turn my gears back on. Mirror plane, this one. I'm going to do the same thing here. Mirror plane, okay. Okay, so eventually I do have to go through and combine this gear and this gear to one piece, and I will. But I'm not going to do it yet. So I'm going to combine this one into one gear, and then I'm going to turn on this. I need to move this. Okay, I made that 0.4 thicker than it needs to be, which means I need to move it 0.2. That's what it is. One millimeter. 0.2. and then combine this, get rid of my sketch, and then I'm going to extrude out the other side of this, which is only like 0.2 millimeters, so it's nothing really. And there is ring gear number 1. And go do ring gear number 2. So this is going to tell me how far apart. Yeah, 0.6 millimeters is the distance between them. And that's okay, you know. I'm going to leave it that way. I'm not going to go and try to fix it. So now that I don't need this ring gear from the other gear set anymore, I'm going to go Control, Remove. And the reason I use Remove is because if I deleted that gear, I would actually lose the reference points that I used here and here when I took that sketch, and the reference point for the diameter of this. I would lose all that information if I clicked on it and hit delete. So here is the entire gear set at this point. So now I'm going to get rid of my ring gears, just get them out of the way, because right now I'm going to combine all of these gears. I'll probably fast forward through this part because it's really boring, but this is all I'm going to be doing. Just a join. Yep. Okay, so one thing I wanted to point out is I went ahead and I patterned these bodies before I mirrored them, and that was kind of a mistake on my part because it would have been a lot easier actually to mirror them and then do the pattern on them. And that, you know, I didn't think of that when I started doing the pattern on them. But if I would have done it that way, I wouldn't have had to do a mirror on each individual one and then a combine on each individual one. I would have only had to do it once. Now there is a reason that I'm drawing this with all 5 gears, and the reason is because all 5 of these gears are actually different, and that when I get to combining this gear with this gear, when I get to making a piece to go between them, it's going to make this gear specifically different, this planet gear completely different from this planet gear, and that's why I have to do it, model it with all 5 of them. Okay, so now I'm going to make this my active component and do the same thing to make the 4th module. So now I have to go and redo all these lofts that I did before. So I'll fast forward through this, but I'll show you the first couple of them here. I'm going to combine all of these planet gears. And then figure out which component this is and get rid of that whole line of them. Let me get these sun gears out of here too. Now I'm going to do the same thing 5 more times. On this, the problem here, if I select this gear and then I do a loft to this gear, it says this loft will intersect itself, which is weird because I've done it many other times. But if I select this gear and do a loft to this gear, it works just fine. Now what I'm seeing from this design and what I realized I should have done is I should have done the handedness of the gears. I should have made the first one have a right-handedness on the ring gear and planet gears, and the second one had a left-handedness, because then when I came to do this loft, I would have, it would go up, down, and it would almost continue going down and then back up. If I would have done it that way, it would have been easier to print, because on some of these, I see an issue where it's going to be slightly hard for the printer to change directions like this and to make maybe this overhang here. And it might have been easier for printing and maybe even looked better is what I'm thinking of, to have it so it's got a constant pattern to it, more so than it does now. So this is where I'm at right now. I have 2 ring gears, but I need 4. I also only have 2 sun gears, but I need 4. So let's fix that. So ring gear number 1 is identical to ring gear number 3. And because I don't often like to explain that to people, I just make 2 of them. And ring gear number 2 is identical to ring gear number 4. So I will soon label these with a number so that it's easy to identify how to put this gearbox together. That's usually the last thing I do though. I'm going to copy sun gear number 1 over to sun gear number 3 position. So now I'm just cutting out the hole for the NEMA 17 motor D shaft. Okay, so now I'm getting pretty close to done. I just cut my hole in the sun gear to drive it with the stepper motor. What I have left to do is to label every ring gear 1, 2, 3, 4, to label the planet gears 1, 2, 3, 4, and to shit, I think that might be it. So I need to make a way to write numbers right on here, and that's kind of hard to do. Like, where do I get a sketch plane from that I can write something on right there? Because it isn't a flat surface. I can't create a sketch on this surface here, and this is a round surface too. Because this surface here is actually round. It's the diameter of the outside of all these notches. So what I'm gonna do is I'm going to go extrude, and I'm going to pick a flat surface. This one's flat, and I'm just going to make a new body. Well, there's nothing left to do now but test it, I guess. Alright, I'm going to show you guys how to assemble this gearbox. This is very easy. You can make it more complicated than it is, but it is pretty easy. Now take sun gear number 4 and set it right in the middle, and then take the one-piece sun gear. This is for modules 1 and 3, and it doesn't contact module 2. So you take this sun gear and set it right on top of that one, and then you fold all of these around it. Now don't worry about getting these upright, just make sure you have it so that in a clockwise direction they're 1, 2, 3, 4, 5. Okay, now you want to take ring gear number 1 and clip it right around all of these planet gears. So now it's holding all of these planet gears in, but the hard part here is getting them all arranged correctly. Now, because if you have this gear in here, it's a lot easier. Don't try to assemble this without this number 4 planet gear, or sun gear rather. Now, if you have this number 4 sun gear in here, it's a lot easier to assemble it because then you can hold it right from the sun gear as you move each planet gear individually. So now I've got all of the gears in there. And what I'm going to do is I'm just going to move them around in here until I get them all on their marks. And I'll give you a look at them right there. So here's an example of how not to align the gears. This ring has marks around the outside, and this sun gear has marks on the inside. And if you look at the pictures on Thingiverse or some pictures in this video, you will see how I actually designed the gears to fit in here. So planet gear number 1 gets lined up with this first mark on the top right side of the ring, and you can see the mark that goes across it. So there's a number there, and then there's a line that crosses through the number that's not quite as deep, and those are the marks that I'm talking about. And then the other thing is you want to make sure that the sun gear orientation is right. Otherwise the lines won't line up with anything on any of the gears. So it's important on this one, actually, if you want to use the marks, which makes it very easy to assemble, it is actually important to reference all these gears to each other, but also to the ring gear and to the sun gear, and that will let you use those marks. So if you look at the sun gear and you see that it has this flat spot, this D shaft flat spot, that should be perpendicular, just about perpendicular to this line here, and point that kind of towards planet gear number 1, and then line that up with this mark on ring gear number 1, and then from there everything else should line up perfectly. So anyways guys, thanks for watching this video, thanks for supporting the channel. Don't forget to like, comment, share, subscribe. If you want this Arduino program, let me know in the comments. Maybe I'll give it away. I just might.